Hi, so welcome back to our final video. In this video, I just wanted to show you some of the applications of what you've been working with so far with sets. In Python and other programming languages, you can work with sets as a data structure. If you're not interested, you don't have to view this video. This is just some supplementary material. But to operate Python for free, if you go to py3.codesculptor.org, don't forget that's a K and not a C, you can actually go ahead and try your own code as well. So in Python, to be able to define a set, this very first line here, A equals set parenthesis, and then the list of elements out of which we would like to create the set, separated by commas. So if I run this, this creates set A, and it contains the elements, wait a minute, 2, 5, 4, 1, 3, I thought it was 1, 2, 3, 4, 5. Well, obviously already you can see that a set is unordered. So in fact, every time I run this, you can see the output is different. That is a beautiful thing with data structures, where if you define a set, it doesn't take up as much memory because these elements do not have to be sequenced. So removing the sequencing where it's applicable can be very helpful. So now I'm going to define a set B. And so then my print statement here just says print the word or the text set A colon, and then comma, and then print the value of capital A. Then I created another set, B equals set, consisting of the elements 2, 4, and 6, and then we'll go ahead and print that. And you can see, again, every time I run this, those elements kind of get jumbled. And that's the beauty of a set. They don't have to be ordered. So now we can do some things like operate on them. So if we want to, let's say, take A union B, to do that, you would do A dot union parenthesis B. And so when we run that, those two sets get unioned together, and you can see that they contain 6, 2, 1, 3, 4, 5, or 1, 2, 3, 4, 5, 6. The only element that's unique to B that's not already part of A is the element 6, so that's the only thing that got changed here. Now I can also do the opposite. I could take B union A, and although the ordering is not the same, we should get exactly the same set. When you union things, you just grab them and put them all into one bucket. Now what we can do is look at intersection, so similar kind of operation, A dot intersection parenthesis B close parenthesis, that will print the intersection. So if I look back at these sets, I see that 2 is in A, 2 is also in B, 4 is in A, 4 is also in B, but 6 is not in A, so that's not going to print. So we get the set consisting of elements 4 and 2. And when I do B intersection A, I also get the same two elements. Again, the order doesn't matter. So we can also look to see if the intersections are equal, which they are, but all I'm doing here is I'm just saying, is it the case that A intersect B is equal to, that's a test for a true or false statement, is it equal to B intersection A? And I should get true, yes, their intersections are equal in the opposite order. The last thing I can do in here is the set difference. So to do A minus B, I would do A dot difference and then B. And so we see that A minus B, that's all the elements that are unique to A. So 3 is unique to A because I don't see it in B. 4 is not unique to A because it is part of B, so we're not going to list that in the set difference. A is not different in the element 4. 5 is in A, it's not in B, so I should see that in the set difference. 2 is in both, so A is not different in that way. And then 1 is in A, but it's not in B, so A is different from B by also the element 1. So the elements 1, 3, and 5 are the ways in which A is different than B. And if I print B minus A, let's just analyze this. Well, 2, B is not different in the element 2 because A also contains it. B contains 6, A does not, therefore we should expect 6 to appear in B minus A. And 4, B is not different by A in that element, so I should not see 4. So really I should just get the set containing the element 6. And I do. And every time I run this, notice that things get rearranged. That's just, again, one of those principles of working with sets, that the order in which they appear does not matter. So I hope this has been useful. I hope that this allows you to see that we do use sets on a regular basis. You see these oftentimes in game programming where you have sprites appearing on the screen, like imagine Mario Brothers and the the Goombas, I think they're called. There are many of them, so you can keep track of them in a set since you don't want to uniquely alter their properties, but there are all kinds of cool applications for sets. So I hope this has been helpful.